Good day, this is the Lopi of BCH, and in this video tutorial I'm going to take you through the basics of drawing the double reciprocal plot, which is also called the lineweaver-burk plot. So this is the data, these are the data, and you have it on the question too. Now the first thing you have to realize is that for the lineweaver-burk plot we use 1 over substrate concentration and 1 over initial rates. Therefore the first thing we need is create a new column with 1 over s, and then here we need 1 over v. All right, and right here we need to take the values, the reciprocal of each of these substrate concentration. But to do that, it is very easy. Just write equal to. Equal to means you're trying to give this thing a formula. So you're going to say 1 over, and you click the first value here. So 1 over b8. So you click enter, so it knows that it has done that for you now. All you have to do for the rest, instead of doing it one by one, you just drag it down. You drag it down here and it does the same. So come to 1 over v, you do the same thing, equal to, for your formula, 1 over, you drag the first value of v here, c8, click enter, it has done that for you. And then to do the rest, you just drag it down. And there you have it, your 1 over s and 1 over v. These are the two values that you're going to be using in your graph. So you go ahead and select just these two, your 1 over s and 1 over v. And after selecting that, go to insert and you go to your charts. All right, so for the chart you have a lot of options. You have the line, the pie, the bar. What you need is this xy scatter. All right, so something like this. So you're going to click that, double click that, and there is your graph. All right, there is your graph. Of course, we have to tweak this a little bit. There are some things that we have to do to this. So first, let us clean up the axis. So you're going to come here. You have this to on the right hand side of the graph. You're going to title your axis. So for the x-axis, we are going for the y-axis rather. We know this is 1 over v. So we're going to label it 1 over v. For the x-axis, we also know that this is 1 over substrate concentration, so we're going to label that appropriately. And then for the title of the graph, we know what it is too. So this is the lineweaver-burk plot. Lineweaver-burk plot, and there you have it. Now as you can see, there is no trend line yet. So you can come to this upper left corner, add element, add chart element. You can actually do it by clicking on this data point here. Well, from here you can just say trend line. That is the name of that line. So you're going to choose a linear trend line, and there you have it. All right, but let's make this a little bit, more beautiful. So I like this type of graph. So that's better. Now, if you recall the lineweaver-burk plot, you would know that this line has to be extrapolated onto the negative x-axis. All right, but here it isn't. So to do that, there are a couple of ways for you to do that. But what we need to do is just you can click your trend line here, and then right click, and then you go to the format trend line here. All right, so from this format you have a lot of things you can do. Leave everything as they are and come to this forecast. You can see right there, and come to this move down. This is telling you to move it down. All right, so here I am going to input 100,000 because of the unit I have on this x-axis. So I'm going to input 100,000 and I'm going to press enter. As you can see, it has extrapolated it onto the negative x-axis now. Now the next thing you need to do is look for the equation of this line. If you remember your general equation for a straight line, y equals mx plus c. How do you get this equation? It is right here. Look at this option that says, look at this checkbox. It says display equation on chart. So all you have to do is click that, and there you have it. You have your equation on the chart. Your equation now, your straight line equation for this graph is y equals 7 times 10 raised to the power minus 8 x plus 0.0071. If you compare that to your general equation of a straight line, you already know that your y-intercept c is 0.0071. Your slope now is 7 times 10 to the power of negative 8. So we have our graph already. how do we solve the question? The question says look for Km and Vmax. I have done the majority of the work down here, but I'm going to walk you through it. All right, so first I started with the equation, the lineweaver-burk equation, the famed one. All right, so I compared it to your general equation of a straight line, y equals mx plus c. All right, so in this case, your slope m corresponds to Km over Vmax. Your y-intercept c corresponds to 1 over Vmax right here, and then your x-intercept. You can find this on the graph that I drew on the first page, of this post. All right, it is negative 1 over Km. Now the calculations, the first thing we want to calculate for is our Vmax. Recall from this equation that we have, from this equation of a straight line, our c, which is the intercept, is 0.0071. All right, so you come back here and say your c, which is your y-intercept, is equal to 0.0071. But what formula does c stand for? 1 over Vmax. So you are going to equate those. And what are we looking for here? Vmax. So you cross multiply. If you cross multiply this, you're going to have Vmax multiplied by 0.0071, and everything is going to be equal to 1. And then from here, you can make Vmax subject of the formula by dividing both sides by 0.0071. And on doing that, you should get your answer to be 140.85. All right, for your Vmax. All right, so now for your Km, to calculate your Km, there are two methods, and I explored the two methods here. All right, so the first method, recall that your slope m is Km over Vmax. Your slope m is Km over Vmax. But the slope from the graph, look at it here. This value after y is your slope before x. 7 times 10 raised to the power minus 8. That's what you have there. So come back here. You have your slope equals Km over Vmax, but the slope itself, that m, is equal to 7 times 10 to the power of negative 8, and your Vmax, we just calculated it to be 140.85. All right, now we set up our equation. Since the slope is equal to Km over Vmax, we input the known value. Slope is 7 times 10 to the power of negative 8. Km is unknown, so we write it there. Vmax, we know it, so we input it there. Same thing again, we cross multiply so we can make Km subject of the formula. And when you multiply this, you're going to have this final answer, which is 9.86 times 10 to the power of negative 6 molar. All right. Now let us use the second method and see if we get the same answer. So the second method, recall that your x-intercept from the general graph of this lineweaver-burk plot is minus 1 over Km. All right, and what is the x-intercept from our graph? Let's go back to the graph right here. Look at where the line touches the x-axis here. It touches it at minus 100,000. It touches it at minus 100,000. Therefore, your negative x-intercept is minus 100,000. So you equate it to your minus 1 over Km. When you cross multiply here, you're going to have Km multiplied by minus 100,000 equals to minus 1. And a little bit of mathematics, you're going to get your final answer to be 1 times 10 to the power of negative 5 molar, which is the same answer as before. But you might ask the question, this looks different from what we have. Here we have 9.86 times 10 to the power of negative 6 molar. And here we have 1.1 times 10 to the power of negative 5 molar. And here I am saying it is the same answer. Yes, it is the same answer. How? Now, look at this value that you have here. Look at this value that you have here. What if you want to approximate this value? If you approximate this value, what do you think you're going to get? Think about it. You're going to have something like this. Km equals 0.0000. So 4 out of those zeros. There's 1 0 left here. If you approximate this one down now to this 0, it becomes 1. It becomes 1. And what's that? That is just 1 times 10. 1 times 10. 1 times 10 to the power of negative 5. Which is the same answer. All right, so that is how you plot the graph using this spreadsheet. All right, you can do it on your laptop or your phone. I am going to give a different question another day, so to check if you understand what I did here. Then we are going to be plotting, taking the Hughes plot. You remember, for the binding of hemoglobin, if you guys remember that, binding of oxygen, rather, sorry. All right, so that brings us to the end of it. If you have any question, do not hesitate